Hi, in 6.2, we're going to be learning how to multiply polynomials. So we just finished adding and subtracting polynomials, and now we're going to multiply. So you're going to be able to multiply monomials by various polynomials or binomials by trinomials, and then see what type of results is the expression. In the first set of examples, we're going to be going through multiplying some monomials by different polynomials. So first we have a monomial multiplying by a monomial. And when we have monomials times monomial, we're just going to start with multiplying the coefficients, which means 5 times 6, and that gives us 30. And when we multiply the variable part, if the variable is the same, we're just going to add the exponents. Remember doing that in maybe middle school? So we're going to have x to the 1 plus 3, which gives us 4. And so that is how you multiply a monomial by a monomial. Next, we're going to have another monomial times another monomial. So we're going to start again with the coefficient. So that's negative 2 times 5, which is negative 10. And then we have x squared by itself here. So we're just going to have x squared back. And then x, for the y, we have 4 and 2. That's going to give us a total of y to the 6, because 4 plus 2 is 6. And then we have z and z, that will be z squared. And so that is the answer for the second problem. Next, we have a monomial times a binomial. And when we have that, we're going to actually need to distribute that monomial through both terms in the binomial. So that's 2x times 4x, which gives us 8x squared. And then we're going to distribute the monomial to the second term, which is 2x times negative 1. That gives us a negative 2x. And so that is the end of that problem. So next one, we have a monomial times a binomial again. So we're going to distribute. We have negative 12, and then we have x to that 2, and 2 gives us 4. And then we distribute negative 4x squared times 3 gives us a negative 12x squared, and end of that problem. And then finally, we have a 2 by 2. In this case, this is a binomial times binomial. So I'm sure you guys, most of you have heard of foiling. FOIL means we're just going to take turn with the parentheses, first one multiplying the second one. So we got the first term in each parenthesis. So that's 2 times 1. So that's FOIL. F-O-I-L. So first term is 2 times 1, which is 2. The outer term, second one, outer term is the outside of both parentheses. So 2 times x is 2x. I stands for the inner term. So that's inner, which is 3x times 1, which is 3x. And finally, L for last. The last term in each parenthesis, that's 3x times x, which is 3x squared. So if you think about it, we actually just did distributive property twice. So we distribute the 2 into both parentheses, and then we distribute the 3x into both of the second parenthesis. Next, we're going to just combine the like term, and I always like to leave the answer in standard form. So it does not specify, so you could have different ways of writing the answer, but in standard form, we're going to write the 3x squared first. So we have 3x squared. And then 3x plus 2x gives us 5x. And then finally a plus 2 by itself. And so that is the final answer for the last problem. I'm going to move on to example 1. Perform the following polynomial multiplication. So we are moving on from monomial times monomial or monomial times binomial. What we have here is a 2 by 3. So it's a 2 by 3. In this case, we do not use FOIL, but we just use superfoil. I call it superfoil when we have a 2 by 3. Basically, it works the same way as what we just did. We're going to distribute the first parentheses, the first term in the first parentheses into all 3 of the second parenthesis. So we have x times 6, which is 6x. Another trick that I tell the students to do is to line up the common terms. So right now, I'm going to show you guys the vertical method. So I'm going to multiply 6 times x with 6x, and then we have minus 2x to the third, and then plus x squared. In the next set of multiplication, I'm going to distribute the 8, and watch out, I'm going to be actually lining up by the like term. So 8 times 6 is 48. There are no whole numbers here, so I can just like put it on the side in the front. So that's 48. Next, I have 8 times negative 2x squared. That's going to give me a negative 16x squared. And then finally, 8 times x is 8x. So we're going to go ahead and actually draw a line to indicate the vertical adding. We're going to add the 2 rows up. And so we're going to have 48 by itself, and then plus, notice that these are like terms so that we can go ahead and add them up. And there is no like term here. That's a minus 2x third, which is going to bring it down. And then these two will give me a minus 15x squared. So that would be the answer, except we want to make this look a little bit cleaner. So we're going to actually line this up in standard form. So we're going to actually put the negative 2x to the third first, then minus 15x squared plus 14x, and then plus 48. So that will be your final answer. So always clean it up and then put it in standard form at the end. We're going to try one more just like that. So we're going to distribute the 2x into the second parenthesis. So we have 2x to the third plus 8x minus 10x squared. Next, I'm going to distribute the negative 3. So it's going to be a minus 3x squared. And I'm going to line it up by the like term. So that's 3x squared. And then we have a minus 12. Notice there's no like term on top. So we're just going to put it at the side, minus 12. And then distributing the last term, we have negative is positive, 15x. And that's all of the terms there. So we're going to combine everything. 2x to the third is by itself, so I'm going to bring it down. And then I have a plus 23x. And then I have negative 13x squared minus 12. It is a little bit out of order, so we're going to rearrange it and put the terms in standard form. And that should be the final answer for this multiplication right here. And then lastly, we're going to do the last one. So we have 2x. This one you can actually, I always like to distribute the one with the 2 parentheses into the 3. So I'm going to multiply backwards. So that's 2x squared y squared. And then plus x y to the third. And then minus y to the third. And then the next term is going to be a little bit messy, so let me try to change the color. So we have 3x times 2x squared. That's going to be 3. That's going to be plus 3x to the third. I don't have any x to the third terms, so I'm going to just add it to the back here. And then next I have 3x squared y. So we have no x squared y either. And then finally we have a minus 3xy. I don't have any 3xy term. It turns out that every single one of these terms are different from the previous terms. So that is the final answer here. And we're going to have you guys try these 2 problems here. So you guys are going to pause the video and try the problems on your own using the superfoil method that I just showed you right now before you look at the answers. So first, hopefully you've had a chance to try the problems, and I'm going to go ahead and work out the solutions. 3 times 4 is 12, minus 21x, and plus 15x squared. Next we have plus 8x, so put it underneath the like term. And then we have a minus 14x squared. And then finally a plus 10x to the third. Going to bring down the like terms, and we have 12 by itself minus 13x. And then we have a plus x squared and then plus 10x cubed. I'm going to rearrange it again in standard form. So I have 10x to the third plus x squared minus 13x and a plus 12 as my final answer. And that's the end of that problem. Next, again, we're going to distribute that x in through the second parenthesis. So I have 4x. So 4x plus 48. Oh, sorry. We're going to actually have plus a minus 8x squared. And then distributing the last term here, we have a minus 4x to the third. And next, we're going to distribute the second term through both, everything in the second parenthesis. So we got negative 24. And notice there's no like term, so I'll just put it on the side. And then we have plus 48x. And then plus 24x squared. I'm going to line it up. And I have a negative 24 by itself plus 52x plus 16x squared and then a minus 4x cubed. Again, we're going to line it up using the standard form. So I have negative 4x to the third plus 16x squared plus 52x and a minus 24 in the back, and that is the final answer. Next, we're going to look at some real-world problems, how polynomial multiplication is used in real-world problems. A biologist has found that the number of branches on a certain tree in its first 5 years of life can be modeled by this polynomial here. The number of leaves on each branch can be modeled by this polynomial, where y is the number of years after the tree reaches a height of 6 feet. And write a polynomial describing the total number of leaves on the tree. So I'm just going to briefly draw a tree here, and it's talking about, you know what, I'll just draw a better tree. So here we have a tree, and we have these branches, and on each branches there are y squared plus y branches, and each branch has leaves, and so here are the leaves in each, so they all look kind of like that. And then they want to know then the polynomial describing the number of trees. So we've got to start by counting how many branches are there. So we're going to actually, this turns out into a multiplication problem. So the polynomial is going to be given by the number of branches, y squared plus y, times the number of leaves on each branch. And so we're just going to distribute this 3 to get the answer. We're going to distribute the first one. We have y to the fifth. Second one plus 3y to the fourth. And then plus y to the third. And then distributing the second one, we have y to the fourth. And plus 3y to the third. And then a plus y squared. I'm going to finally combine it all together. So the polynomial p of y, actually, p of y is equal to y to the fifth by itself plus 4y to the fourth plus 4y to the third and plus a y squared. So that's the polynomial that represents the total number of leaves on the tree. And that's the end of the problem. Next, we're going to take a look at some special polynomials products. The first one is called the difference of square. So some of you may have heard of a difference of square, and that's when you have the difference, which means two perfect squares subtracting each other. And so, for example, I'll give you an example, x squared minus 9. We can rewrite that as x squared minus 3 squared. So now a equals 3, right? So now we can factor that into an x plus 3 and x minus 3, because when you FOIL this, you're going to get x squared minus 9 back. Another example would be x squared minus 100. So you want to make sure that both of the terms are squares. So that's a square right there, and that 100 is 10 squared. So you can again factor it into x plus 10, x minus 10. So that's how you recognize a difference of square. And likewise, we're going to do the next one, which is just only to verify that, in fact, I will be getting a cubed minus b cubed from these two polynomials multiplying together. So we're going to just follow the same rule that we did earlier. We're going to distribute the first term through each one of the second parentheses. So that's how we're going to do it. So we're going to have a to the third plus a squared b plus a b squared. Next, we're going to distribute the negative b through. So we're going to have negative a squared b, and then a negative ab squared, and then finally a negative b to the third. So notice what happens is that these middle terms are going to all cancel out because they are opposite of each other, and that leaves you a to the cube minus b to the cube, and we have just shown that this product is going to give us a cubed minus b cubed. So I want you guys to try the next one because it's the same exact thing except the signs are switched. So you guys are going to use superfoil to verify the answer. So go ahead and pause and try it. Hopefully you've had a chance to try the problem. So we're going to distribute this for you and show the answer. So first we have distributing the a through. We got a to the third minus a squared b, and then we got plus ab squared. Next, we're going to distribute the b through. So we got plus a squared b minus ab squared, and then finally plus b to the third. Again, notice that the middle terms actually will cancel each other out, leaves you a to the third plus b to the third, and that we have just shown is obtained by multiplying those two polynomials. So that's basically how you verify it. And that is the end of the lesson. Today we only have one video for lesson 6.2. So you will just only be doing work for 2 days, but only 1 day of notes. So you will be referring to this video for both days. Go ahead and log into Google Classroom and get started with your assignment. Have a good day.